Somewhere tonight, you will probably look up at the sky and wonder if anyone is out there, some other intelligence in some other world staring back. It's one of the oldest questions your species asks. But the real answer might be far stranger than anything looking back at you. What if the question is backward? What if you're not the one searching for aliens? What if you already are one? That sounds like science fiction. Stay with it anyway, because some of the most serious scientists of the last century took this idea completely seriously, and the evidence they gathered is stranger than most people realize. Start with a basic problem. Life on Earth appeared remarkably fast. The planet formed around 4.5 billion years ago, cooling from a molten, hostile ball into something with liquid water. And yet, the earliest evidence of life, simple microbial life, shows up in the geological record as early as 3.7 billion years ago. That leaves a window of maybe a few hundred million years for something as complex as self replicating chemistry to spontaneously assemble itself out of raw, lifeless minerals and water. Is that enough time? Some scientists have looked at that window and said quietly, maybe not. In 1973, molecular biologist Francis Crick, one of the two men who unraveled the structure of DNA, published a paper with chemist Leslie Orgel that proposed something audacious. They called it directed panspermia. Their argument wasn't fringe speculation, it was a serious hypothesis published in a respected scientific journal suggesting that life on Earth might not have originated here at all. It might have been seeded deliberately or accidentally by an intelligent civilization elsewhere, sent out into the cosmos on some kind of primitive spacecraft, landing on a young, empty Earth billions of years ago. Crick wasn't claiming certainty. He was pointing at a genuine gap in the science and asking an uncomfortable question. Why does life on Earth use the same basic genetic code? The same 20 amino acids, the same fundamental chemistry, everywhere you look, from bacteria to blue whales? Is that simply what life always converges on? Or is that the signature of a single common starting point, one that might have arrived from somewhere else entirely? Around the same period, astronomer Fred Hoyle, along with mathematician Chandra Wickramasinghe, pushed a related idea even further. They argued that the raw ingredients for life, complex organic molecules, might be far more common throughout the universe than anyone assumed. Drifting through interstellar space, riding inside comets and asteroids, occasionally seeding new worlds the moment conditions became survivable. For decades, this sounded like fringe theorizing. Then the evidence started catching up. In 1969, a meteorite crashed near Murchison, Australia. When scientists analyzed its fragments, they found something remarkable: amino acids. The literal building blocks of proteins, the molecules every living thing on Earth depends on, embedded inside a rock that had formed in space long before Earth even existed. Researchers, including chemist Sandra Pizzarello, spent years studying the Murchison meteorite in detail and confirmed dozens of different amino acids inside it, some barely found in Earth's biosphere at all. This wasn't contamination from Earth. The chemical signatures were distinctly extraterrestrial. So the raw ingredients for life, the letters of the biological alphabet, really do appear able to form in the vacuum of space, riding on rocks, drifting for millions of years, occasionally crashing into young planets like a very slow, very cold delivery system. Doesn't that reframe everything? You're not necessarily the product of a miracle unique to this one blue planet. You might be the product of chemistry that happens constantly, quietly, throughout the galaxy, and Earth simply happened to be a good landing spot. Now push the idea one step further, the step that gives this entire theory its real bite. If simple organic molecules can travel between worlds, could something more complex? Could actual microbial life, dormant and radiation shielded deep inside a rock, survive the brutal vacuum of interstellar travel and arrive somewhere new, ready to take root the moment conditions allowed? Experiments testing extremophile bacteria, organisms that survive in Earth's harshest environments, deep sea vents, Antarctic ice, high radiation zones, have shown some species can endure conditions startlingly close to what a journey through space would demand. Not proof. but not impossible either. Which brings you back to the strange core of tonight's question. If life's basic chemistry can travel between worlds, if Earth's earliest life appeared almost too quickly to have assembled itself from scratch, if every living thing on this planet, including you, shares a single unbroken chemical thread stretching back to one common ancestor whose true origin nobody can fully explain, then the label alien stops meaning something foreign to Earth. It starts meaning something foreign in origin, full stop. And by that definition, every human being alive right now might already qualify. Think about what that does to the search for extraterrestrial life happening right now, funded by governments, run by radio telescopes, scanning the sky for a signal. Scientists are pointing instruments outward, searching for confirmation that we are not alone in the universe. But if directed panspermia, or even simple undirected panspermia, turns out to be true, the confirmation was never going to come from outward. It was always going to come from looking down at your own DNA, at the chemistry running through every cell in your body right now. There's something almost dizzying about that. The greatest science fiction premise your species has ever imagined, first contact, alien life, a civilization from elsewhere reaching Earth, might not be a future event waiting to happen. It might already be sitting behind your own eyes, running the show, wearing a body shaped by 4 billion years of evolution on a planet that may have simply been a convenient place to land. None of this means a spaceship dropped off your ancestors on purpose. Most scientists studying this today lean toward a quieter, less deliberate version of the idea: chemistry, drifting on comets and asteroids rather than intelligent design sending out ships. But the deliberate version and the accidental version share the exact same unsettling conclusion. Your existence may not be a purely local Earth story. It may be a cosmic one, with a beginning that happened somewhere else, long before this planet had a name. So the next time you look up at the night sky searching for some other intelligence looking back, consider flipping the question entirely. You might not be looking for the aliens. You might be looking for home. What if the search for life beyond Earth was never really about finding someone new? What if it was always about finding your own beginning, scattered across a universe you already came from?